Hello students, this is JYOTSNA madam from Department of Chemistry. So in today's class, let us discuss about the structure of atom. In general, we call it as atomic structure. In the atomic structure, there are several different models of the atom. For example, Thomson's model of atom, which is also called as plum pudding model. Also, we have Rutherford's model. Since these models have limitations, further, the theory of these atoms were studied by Bohr. Hence, we have the Bohr's model of the atom. So, before going to the Bohr's model of the atom, let us take a look. What are the developments that has led for the Bohr's model of the atom? So, coming to the developments leading to the Bohr's model of the atom. First one is the dual nature or dual character of electromagnetic radiation. What is this dual character? That is two different characters. One is the wave-like character and the other is particle-like character of electromagnetic radiation. The other point here which led for the Bohr's model of atom is the atomic spectra was explained only by assuming quantized electronic energy level in the atoms. So further we shall discuss about this in this chapter. So these are the two reasons which led to the Bohr's model of the atom. Now we spoke about the term electromagnetic radiation. So what does this electromagnetic radiation means? Electromagnetic radiation was introduced by James Maxwell. According to him, he suggested that when the electrically charged particles move under the acceleration, alternating electrical and magnetic fields are produced and are transmitted in the form of a wave called as electromagnetic radiation or electromagnetic waves. So this is a kind of the radiation which is produced by the charged particles by accelerating, which produces the electrical and the magnetical field and which are transformed or transmitted in the form of a wave. After knowing what is meant by electromagnetic radiation, let us look for what are the nature of this electromagnetic radiation. Coming to the electromagnetic radiation, since we have spoken that they have dual nature, one is the wave nature and the other is the particle nature. So first let us talk about the wave nature of the electromagnetic radiation. In short, I have written it as EMR, which means electromagnetic radiation. This is just to write the short form, but it is not an official short form. So the wave nature of electromagnetic radiation. So what are the important characteristics of this wave nature of electromagnetic radiation? So the first important character is these electromagnetic radiation propagate through the space in the form of a wave. So as we are talking about wave nature, these radiation are going to pass, they are going to move in the form of a wave and they are passing through the space. These radiations travel with the speed of light. These radiations can be any radiations. These electromagnetic radiations in the vacuum are going to travel with the speed of the light. So what is the speed of the light? So the speed of the light, which is represented by c, is equal to 3 into 10 raised to 8 meters per second. So with this speed of the light, all these electromagnetic radiation transmit in space. These electromagnetic radiation do not require any medium to travel. For example, if we want to observe the sound waves or the water waves, they require a medium. So water waves, in the sense, you must have seen, if you throw a small stone in the still water in a lake or in a well, you can see that there are certain vibrations. Those vibrations are nothing but waves, but to transmit, they require the medium, that is water. Similarly, if you take sound, sound also propagates in presence of the medium, that is air. If there is no air, you cannot hear any sound. But these electromagnetic radiation do not require any such medium. They can travel through space. For example, you must have heard about the ultraviolet radiation which reach our Earth's atmosphere. This ultraviolet radiation is also one form of the electromagnetic radiation. As you know that ultraviolet radiation, we say that it comes from the sun and it reaches the earth. So from the sun to the earth, there is vacuum. Once it enters the earth, then there is Earth's atmosphere. But from the sun till the earth, it is going to propagate in the space where there is vacuum. So therefore, these electromagnetic radiation do not require any medium to travel, but they can travel through the space. And the energy, the electromagnetic radiation's energy, is directly proportional to its frequency or is inversely proportional to its wavelength. So we shall look for what does these term frequency and wavelength mean. The oscillation of electric and magnetic field produced by the oscillating charged particles, which creates the electromagnetic radiations, are perpendicular to each other, and they also propagate in the perpendicular direction. So the propagation is also in the direction of perpendicular. So these oscillating electric and magnetic field are produced by oscillating charged particle which are perpendicular to each other and to the direction of the propagation of the wave. Now let us take a look of the terms which are used to describe the wave. First one is wavelength. So what is meant by wavelength? This wavelength, it is the distance between two successive crests or two successive trough. Now, what does this mean? Suppose if we take this is the wave. So when we take this wave, you can see the distance between these 2 points or these 2 points is nothing but it is called as the wavelength. Wavelength is represented by the symbol lambda. It has an SI unit of meter. Next to that, we have the next term called as velocity, which is represented by the small letter c. So what is velocity then? It is the distance traveled by a wave in 1 second. As we take second as the SI unit, here we are going to talk about the distance traveled, which is also measured in terms of meter. Hence, velocity is having the unit of meter per second. So velocity is what? It is the distance traveled by a wave in 1 second. And the velocity of the light or electromagnetic radiation in the vacuum is having the value of 3 into 10 raised to 8 meter per second. One more term which is used here is frequency. So frequency means what? It is the number of waves which pass a given point in 1 second. So if you are going to consider one point in this, through this point in 1 second, what are the number of waves which you are passing? That is called as the frequency. It has the SI unit of per second, or it is also expressed in one more unit called as hertz, named after the scientist. So we write it in the form of Hz. This is the symbol for hertz. So frequency can be either per second, or it can be what? It can be hertz. Then what is the relation between these three terms, that is wavelength, velocity and frequency? So these three are related by the equation C is equal to nu into lambda. So this nu is what? It is nothing but it is the frequency. So frequency can be represented by the symbol nu. C stands for velocity, nu stands for frequency, lambda stands for wavelength. So C is equal to nu into lambda. Next to that one, we have one more term, that is wave number, which is represented by nu bar. So the number of the wavelengths in unit length is called as wave number, which is the reciprocal of the wavelength. Now let us take a look of electromagnetic spectrum. So what is meant by electromagnetic spectrum then? The arrangement of different types of electromagnetic radiation in increasing order of wavelength or decreasing order of frequency is called as what? Electromagnetic spectrum. So whatever the different types of the electromagnetic radiations are there, they are being arranged in an order. In which order? In the order of increasing wavelength, or it can also be decreasing frequency. So this order of arrangement of the electromagnetic radiation is called as the electromagnetic spectrum. So just let us take a look of this one. Here we can have the different types of the electromagnetic radiation. For example, we have the gamma rays. We have the X-rays. X-rays, as you have come across, usually for the fracture of the bone, we make use of the X-ray. Next to that, we have the ultraviolet region, and next to that one, before infrared region, we have a small portion called as visible region. Then we have infrared region, IR region. Then we have microwave. Then we have FM and AM. These are called as radio waves. Now this arrangement of the electromagnetic radiations in the increasing order of their wavelength is called as electromagnetic radiation. Now let us take a look here. Here we have considered 10 raised to minus 16 meter. So we are taking this in terms of meter. So 10 raised to minus 16 meter. This is 10 raised to minus 14 meter. This is 10 raised to minus 12 and so on. So we have, you can see minus 16, it is coming up to 10 raised to 0, and then we are going to increase from 10 raised to 2, 10 raised to 4 on, so on. So in the increasing order of their wavelength, we have arranged. Here we start with gamma rays, X-rays, ultraviolet rays, visible region, IR radiation, microwave. Microwave, I think you have come across in the ovens. You are going to get the microwave oven. So for that, this microwaves are used. Radio waves, I think you have come across this FM. So you are going to get these waves called as the radio waves, which are in the range of 10 raised to 0 to 10 raised to 2 and so on. In this part, we have a small region called as the visible region. This visible region is between 400 nanometer to 750 nanometer. 1 nanometer is equal to 10 raised to minus 9 meter. So this is the unit which we are using here. So here we have 400 nanometer to 750 nanometer. In this range, our eyes can see the radiation. So because of that, we call it as the visible region. So this visible region ranges from approximate 400 nanometer. It is more specific, 350 to 360 nanometer, or even considered as 380 nanometer. So from that range to 750 or 760 nanometer is considered as the visible region. So in that one you have these rainbow colors, that is violet, indigo, blue, green, yellow, orange and red. So because these are seen to our eyes, we call this region as the visible region, which ranges approximately from 400 nanometer to 750 nanometer. This arrangement of different kind of the electromagnetic radiation in the increasing order of their wavelength is called as electromagnetic radiation. So that's it for today's class. In the next class, we shall take a look of the different kinds of the problems.